So now the next topic which we are going to discuss is security concepts in the cloud. Now, one of the important element of discussing the security concepts in the cloud is cryptography. So cryptography is a very critical element when we are talking about from CISSP and from CCSP point of view. In both the certifications, even in the CISSP and in the CCSP, usage of cryptography is there and it is testable in the exam. So now when we are talking about a cryptography, individuals and organizations, they use cryptography on a daily basis to protect their privacy and keep their conversations and data confidential. So now when we are talking about cryptography, it ensures confidentiality by encrypting sent messages using an algorithm with a key only known to the sender and the recipient. So now when we are talking about cryptography, so we have a crypto and we have a graphy. Now what is the thin line difference between both? Crypto means your secret and graphy means science of writing. Science of writing. So now when we are talking about a cryptography, in cryptography team there are different kind of topics. So like we have a symmetric cryptography, we have a symmetric cryptography, and we have a asymmetric cryptography. So live example I can give you of symmetric cryptography. In our laptops, in our office provided laptops, the BitLocker drive encryption which we are using. In our office provided laptops, we have something called as a TPM, right? And in that TPM, we use the TPM to enable a BitLocker drive encryption. We use the TPM to enable the BitLocker drive encryption. That is our symmetric cryptography, which works in the AES, which uses the AES algorithm. When I am talking about asymmetric cryptography, your asymmetric cryptography is basically live example of a asymmetric cryptography is your public and private key certificates. Public and private key certificates which we are using. So normally, let's say if I want to, when I say public/private key certificates, so your public CA certificate authority, in the internet, we normally use the asymmetric cryptography. So where the data is encrypted with half of the public key and it will be decrypted by only the other half of the private key. So this is your asymmetric cryptography. Now in the asymmetric cryptography, there are different kind of algorithms we have. So like we have a RSA is there, we have a El-Gamal, we have a ECC, then we have a Diffie-Hellman algorithm, then we have your quantum cryptography. There are if we start discussing that, there are huge number of algorithms which comes under the cryptography. But the summary of a cryptography is that it is used to protect the confidentiality and integrity of the data by encrypting the send messages. So only the person who has the key, they will be able to decrypt it and no one else. Now in the cloud, we have two types of data. Okay, in the cloud, we have a two types of data team. One is we have a data in transit and one is we have a data at rest. Okay, in cloud, we have a two types of data. One is your data in transit and one is your data in rest. Now, when I am talking about data in transit, so where we have a system A, and we have a system B. Now, both of these systems are communicating with each other. In this case, we can say that it is data in transit. The data which is stored on our internal disk, the data which is stored in our pen drive, in our laptop, in the server storage, or let's say the data which is stored on your AWS S3 bucket, or the data which is stored on the AWS, your Azure blob storage. They are all example of data at rest. So now when we are talking about using cryptography to protect the data in, now the first thing is we are going to discuss how we are going to use cryptography to protect the data in transit. And then finally we will discuss how to protect the data at rest. So now how to protect the data in transit? In order to protect the data in transit, the first and foremost method which we have is a SSL and TLS certificates. Okay, the first and foremost method which we have is your SSL and TLS certificate. One big example of an SSL certificate, SSL and TLS certificate I can give you is when you visit your Amazon.in or Flipkart.com website in your web browser or even in your mobile, that entire website is hosted on an HTTPS protocol. That entire website is hosted on a HTTPS protocol using the SSL and TLS certificate. Okay, so SSL certificate team, SSL is now depreciated. SSL, it earlier we normally used to use SSL, which uses public and private keys, and it uses asymmetric encryption. But now the SSL certificate, after the recent vulnerability, SSL Poodle vulnerability, now SSL is being depreciated. So instead of having an SSL, we have something called as a TLS. We have something called as a TLS. So TLS is a mechanism by which we can connect two different application via a TLS handshake. So now in this case, let's say I have a client. Okay, let's say I have a client and I have a server. I have a client and I have a server. Now, when I am talking about TLS, so the client sends a session, that client sends an information to the server that they want to initiate a TLS connection. That they want to initiate a TLS connection. So now the TLS connection will be established between the client and server by using a process which is, we call it as a TLS handshake. We call this process as a TLS handshake. So there will be a TLS handshake which will be done between the client and the server. Now, when the handshake is done, during that time, the client and server will also establish a shared secret. The client and server will also establish a shared secret, or also called as a session key. The client and server will also establish a shared secret, which is called as your session key, by which whatever data is being sent between the client and server, entire data will be encrypted by using the shared secret. So this shared secret is going to be common, which will be established during the TLS handshake between the client and server. That is the reason why we mention that it's a mechanism which connects two different applications via a TLS handshake, where they agree on the encryption settings which they are going to use. They will also establish a shared key, which is a symmetric encryption, which is used to encrypt and decrypt the traffic. Now, the most of you who doesn't know what's a shared key or a symmetric encryption, in a one line, I can give you a best example. Symmetric encryption means where sender and receiver both are using the same key to encrypt and decrypt the data. Both the sender and receiver are using the same key to encrypt and decrypt the data. This kind of concept comes under the symmetric encryption or shared key. Now there are multiple versions of TLS which we have, team. So there are multiple versions of TLS, but from the exam point of view, you need to remember that the TLS version 1.0 and TLS version 1.1, they are no longer secure. They are no longer secure. So from the exam point of view and even from the knowledge point of view, you need to remember that if you are planning to use a TLS between the two applications, it's better that you use a TLS greater than version 1.1. TLS 1.0 and 1.1 has become obsolete and it's no longer secure. So we have a SSL and TLS. We have a SSL and TLS by which we can protect the data in transit. However, now the question is whether your SSL and TLS. So now when we are talking about the SSL and TLS, also you need to remember from the exam point of view that SSL is a DES. SSL in the backend, it uses DES encryption, and TLS uses your AES. TLS, it uses your AES. So this is something which you need to remember from the exam point of view. So as I mentioned that the SSL has become obsolete, it is no longer used. So if you are preparing, when you are preparing for the CCSP or CISSP exam, you need to remember that SSL has become obsolete. So SSL is your DES. In the backend, it uses DES encryption, and TLS, it uses the AES. So this is one way of protecting the data in transit. The second way of protecting the data in transit is by using IPSEC. Okay. So second way of protecting the data in transit is by using IPsec. So now we have a site to site IPsec VPN and we have a remote access IPsec VPN. So now if we even in the site to site or remote access VPN, we use the TLS certificate. We use the TLS certificate to protect the data which is being sent from the internet to the intranet. So now in this case, if you can see, we have a site-to-site VPN. So this VPN gateway 1 and VPN gateway 2, they will normally have a site-to-site VPN. Now in IPsec, there are different kind of tunnels which we have. So we have a transport mode and we have a tunnel mode and all. We have a transport versus tunnel mode. We have a transport mode versus tunnel mode. Then we have a AH, and then we have your ESP. There are different kind of protocols which is there. So the ultimate goal of using an IPsec is to protect the data which is sent from one network to another. So in this case, once the VPN gateway and gate 1 and gateway 2, they establish a secure tunnel throughout the internet, the entire data which is transferred using this tunnel will be encrypted. So this is what your site to site VPN is all about. So by using the VPN also, we can protect the confidentiality and integrity of the data. So in the site to site VPN, we are basically using two different sites to connect. In the remote access VPN, we have a device with an IPsec VPN client which is connecting to the backbone of your organization. So normally people who are still working from home post COVID, they normally go with the remote access IPsec VPN. So VPN is also another way by which we can protect the confidentiality and integrity of the data which is exchanged over the data in transit. Now the next is we are going to discuss now the next is we have to discuss the data at rest. So now when we are talking about data at rest, now when we are going to talk about data at rest, so there are multiple mechanisms by which data at rest. Now when we are talking about data at rest, there are multiple mechanisms by which we can protect the confidentiality of the data. So live example I can give you for data at rest. So we have a office provided laptop. We have a office provided laptop. Normally, you must have seen that in the office provided laptop, always the drives of the laptop will be BitLocker protected, right team? BitLocker protection will be there. So the BitLocker protection, what it does, it completely encrypts the drive. So tomorrow, even if someone, your laptop could be stolen, if tomorrow if you misplace the laptop or if your laptop is stolen, at least the confidentiality and integrity of the data remains protected. So BitLocker drive encryption, in that it uses the TPM based protection. It uses the TPM based protection. But in the ransomware, they normally exploit a vulnerability which was there on your laptop or on your desktop. Now the another example, we also, so in the data at rest, one thing is, we can, if we have a data stored on our laptop, if we have a data stored on our, it can be my laptop, it can be my internal SSD, it can be my internal SSD, it can be my portable drives. I can, protect the data. But there is also something called as, we also have nowadays SED drives. Anyone has an idea what is an SED drives is all about? SED drives, they are called as your self-encrypted drives. SED drives stands for self-encrypted drives. So in the self-encrypted drives team, the moment you store a data in the portable disk or in the portable pen drive, the data automatically gets encrypted. The data automatically gets encrypted. That is the advantage of using a self-encrypted drives. So you must have seen in the, Marvel movies and all, that the moment they store the data, the moment they insert the self encrypted drive, it also, the self encrypted drives which are normally used in the military and all, it also has a GPS signal. So the moment you insert that pen drive, the military will all automatically will be able to track your location, and without the key you cannot decrypt the data. So this is one way of storing a data at rest to provide encryption. Okay, but many of you, so when we are talking about this, is just we are talking about from the encryption point of view for a laptop or on a self encrypted drive. But we are not here to discuss that. We are here to discuss how to encrypt the data on the cloud. So in the cloud, let's say, in the cloud, let's say you people are using Google Drive. You people are using Google Drive. Some people of you must have be using iCloud. Even in the iCloud and all, we have a setting by which we can completely encrypt the data, by which we can completely encrypt the data. Now, I think probably over a 4 or 5 months back, Apple came up with a feature called as a advanced data protection feature, which you can enable. Advanced data protection feature, which you can enable if you are one of those people who are using iCloud on a frequent basis. Now, one of the advantage of using this advanced data protection feature on the cloud is, whatever data you are storing in the cloud, everything is encrypted. Even Apple will not have the key to decrypt it. So one of the advantage of using the iCloud advanced data protection is that entire data which is stored on the iCloud, it is encrypted. Now the problem with this approach is, if you lose the key, if while configuring this, you have to store the key separately, and you have to also mention the recovery email. You have to also mention the recovery email. If by any means you lose the key or you lose the recovery email, then whatever data is stored on your iCloud, it will not be decrypted. You will not be able to get that data back. So this is one way of encrypting the data on the cloud and maintaining the key directly with the customer, rather than allowing the provider to maintain the key. But now my question is, so apart from Google Drive, we also have many other features, like we have a Dropbox is there, right? We have a Dropbox, we have a OneDrive. So now tell me team, in the Dropbox and OneDrive, so let's say I have a user, I have a person called as Mike. Okay, now I have a person called as Mike. Now I have granted a PDF. There is a PDF which is uploaded on my OneDrive. There is a PDF which is uploaded on my OneDrive. Okay, now I want Mike should be only able to read and view. Mike should be only able to read and view, but Mike should not be able to download the PDF file and save it locally on his desktop or on his mobile device. Is it possible? Now, the problem with the free tier account of Google Drive, Dropbox, and OneDrive is they don't have a DLP feature inbuilt in that. They don't have a DLP feature. Yes, so user can mention as save as the moment the moment I mention a read privilege, the moment I give a read privilege, automatically there will be a download icon. If the person clicks on the download icon, they will be able to save the PDF file. But here my question is that I don't even want that download arrow to be available. I don't want that the person should have an option like right click save as and all. That is the reason why in majority, if anyone would have worked, if any one of you would have worked in companies like IBM and all, IBM, they don't prefer using Google Drive, iCloud or Dropbox. IBM uses Box. Have you heard about this Box Drive? Guys, have you heard about this box drive? Now, one of the advantage of using this box drive is that there is an inbuilt DLP in that. In that, I can specifically mention that which people will be able to download. So, if I have mentioned that Mike should be only able to read and view, Mike will be only able to read and view the data. Mike will not be able to download. Mike will not be able to, copy and paste anything on that particular data. So that is happening because we are using a feature called as box, and that box feature comes with the inbuilt DLP by which we can prevent the data from being downloaded. But if you are signing up with a normal your Google account or Dropbox or OneDrive account which comes under the free tier, it doesn't have that DLP settings available. The moment a person has a the moment you given a read privileges, the person will be able to copy the data or download it and save it offline. That is the thing. So these are the some controls by which team we can protect the data at rest. So we have an encryption, we have a self-encrypted drives in the iCloud and all. We can enable the advanced data protection. All these are the methods by which I can encrypt the data which is stored on my cloud device. Now the next and very important element of the CCSP is cloud key management. So now what is your cloud key management? Key management is the management of a cryptography key in a crypto system in order to achieve security in a system. Cryptography algorithms are used to generate keys which are later encrypted and decrypted to provide the requested information in a secure way. So cloud key management regards the service hosted on a cloud and where one can manage the symmetric and asymmetric cryptography keys as on premises. So now when we are talking about the cloud key management, so we have a two types. One is we have a KMS, key management system. We have a KMS, key management system team. In the cloud, the major reason, okay, the major risk when we are talking about in a cloud is who is going to manage the encryption keys, whether the encryption keys will be managed by the cloud provider or whether the encryption keys will be managed by the cloud customer. So now if my organization, if I am planning to host my sensitive data, if I am planning to host my sensitive data, so like I'm talking about, when I'm talking about my sensitive data, let's say I have a PII data, let's say I have a PCI DSS related data, I am having data related to my HIPAA compliance. Okay, I am maintaining data related to the EU customers, like their social security number, their passport, citizenship details, etc. So now when I am having this sensitive data and I am planning to upload this sensitive data on the cloud, the one of the biggest concern in the cloud is who is going to manage the keys, whether the keys will be managed by the customer or whether the keys will be managed by the provider. Majority of the companies due to data compliance and regulation, the customers are not comfortable to let the vendor manage the keys, because if the vendor is managing the keys, there is a probability that the sensitive data might be disclosed, and there also might be a situation of a vendor locking. There is also a situation called as a vendor locking. So now what do you mean by vendor locking? Just I'm giving you a high level overview of a vendor locking. Vendor locking means, let's say currently there is a customer. So we have a customer A. Customer A is using some sensitive data, has uploaded some sensitive data into AWS cloud. Now the customer is using the keys of encrypting that data is managed by the cloud provider rather than the customer A. In that case, tomorrow if customer A want to exit and move to another cloud vendor like Azure or GCP, in that case the cloud vendor may not allow the customer to leave, them. So this kind of situation comes is this kind of situation where the cloud provider is forcing a customer to stay with them, okay, making them as a hostage. This kind of situation comes called as vendor locking. So in order for preventing situation like this, it is always recommended that the encryption keys should always be managed by the customer. Yeah, Bashir, what you are talking about, Bashir, that is a concept of a dual control, where there are two keys. Half of the key will be with the customer one, half of the key will be with another person. Live example of that dual control is your bank locker, right, Bashir? In bank locker, we normally put two keys and rotate simultaneously. One key is there with the customer and one key is there with the manager, right, Bashir? That is a perfect example of a dual control. The same way in the movies you must have seen, in the movies also you must have seen, there are specifically when in the movies they show how to act, nuclear missiles movies, so they punch two keys and they rotate simultaneously. That is all concept of a dual control. So now when we are talking about cloud key management, it regards the service hosted on a cloud and where one can manage the symmetric and asymmetric cryptographies keys as on premises. So encryption key management is a crucial to preventing unauthorized access to sensitive information. Encryption key management is an important when dealing with the security and privacy protection of the data contained, in order to prevent data loss, breach, contamination, and comply with the relevant regulatory requirements. So we have a key management systems, like we have a cloud HSM, and all, which includes the hardware security modules and other cryptography tools which we can use to meet the compliance and data control requirements, which provides additional security benefits. So the examples of reference standards, so we have that are widely used and constrain the KMS design, including the NIST. So we have a NIST, FIPS, common criteria, PCI DSS. They all talk about encryption and key management, that if you are storing a sensitive data on the cloud, who should maintain the keys and all. Always the keys has to be maintained by the cloud customer. Now, what are the risks which are associated with the data encryption? The risks which are associated with the data encryption, one of the primary risks which are associated with the data encryption is the loss of encryption keys, which will lose the data permanently. So as I was giving you an example of a iCloud. I was giving you an example of an iCloud. The moment you have enabled the advanced data protection, the moment you have enabled the advanced data protection, okay, you get a warning. If you lose the recovery key, if you lose the recovery key or the email, the recovery email which you have mentioned, if you lose it, whatever data is encrypted, Apple will not be able to decrypt it because even Apple doesn't have the key. So loss of encryption keys will lose the data permanently. Okay, key access should be restricted based on a need to know basis. So now when I am talking about a key access should be restricted based on a need to know basis, it means what? Let's say I have a server. Let's say I have a server one. Now in this server one, I have some PII data. I have some PII data. I have some PHI data. I have some HIPAA data which is stored on this. So I need to, now this data is basically my encrypted data. I have encrypted this data. Now when I am talking about key access should be restricted based on need to know basis or based on least privilege. Now when I am talking about key should be restricted based on need to know basis or it should be based on least privilege. Whenever you are granting a key, whenever you are granting a access to the key, it should basically based on a zero trust model. So what do you mean by a zero trust model? Zero trust model talks about trust but verify. Okay, so we have a something called as a JITA. We have something called as a JITA. Now what do you mean by JITA? Just in time access. Just in time access. So always the data, always the keys should be restricted based on need to know basis. Now that in order to restrict the key access, you can either employ a zero trust model or a just in time access which is based on the zero trust model only. Okay, so in the just in time access, one live example of the just in time access I can give you is, let's say we have a user one, we have a user one and we have a user two. Okay, now both user one and user two, they have a they are privileged users, they are privileged users. Both user one and user two, they are privileged users, which means they have a clearance level, they have a clearance level to access the server which is hosting my sensitive data. But I have to identify that how many times they need access. Do they need access every day or do they need access once in a month? Okay, do they need access every day or do they need access once in a month? If they need access only on once in a month, I have to identify how longer they need admin access. Okay, does they need admin access only for 15 minutes or does they need admin access for 30 minutes or they need admin access only for a particular day? So now I identify all these requirements and I implemented a just-in-time access where every time user one and user two, when they want to access this sensitive data hosted on this server, they have to give a proper justification and they will be granted admin access only for that particular duration. Let's say 15 to 30 minutes. Within that duration, they have to finish their work and they automatically, whatever access is temporarily granted to their user account, automatically after 15-30 minutes that access will be revoked. This is called as your just in time access. Live example of a just in time access is all the organizations who are using system center configuration manager. All the organizations who are using system center configuration manager, they have a self provisioning self. So in the just-in-time access, what we are doing is we are only provide. So live example I was giving you that in the organizations which are using System Center Configuration Manager, in the System Center Configuration Manager, they have an option team which is called as your self-provisioning portal. In that self-provisioning portal, if you want to have a temporary elevated rights like temporary administrative privileges for your laptop or for your desktop, okay, you want to install some application, you want to test, so you can submit the request from the self provisioning portal. Okay, you have to give a proper business justification and automatically within next 5 to 10 minutes the admin rights will be provided to your user account only for that given duration. that is a perfect example of a just-in-time access which is based on a zero trust model. So when we are talking about encryption keys, the keys should be restricted based on a need to know basis. You can either use the least privilege based on least privilege, or you can employ just-in-time access or zero trust model to make sure only the keys are there with the authorized people. Unauthorized users should not get hold of the encryption keys. In a typical cloud scenario, always the keys should be stored with the cloud customer, not the vendor. Now, one of the another big concern when we are talking about risks associated with the data encryption is how to get rid of a data remnants. How to get rid of a data remnants is equally a concern for the organization, specifically if the data is stored on the cloud. Now let me take a good example. Let's say we have a organization called as a contoso.com. We have an organization called as contoso.com. Now contoso.com is storing their sensitive data. Contoso.com is storing their sensitive data in the AWS S3 bucket. Okay, they are storing their sensitive data in AWS S3 bucket. Okay, they were using the cloud services for the last 6 years, but now they want to move from AWS and they want to go to Azure. They want to move from AWS to Azure. But now the challenge is, as a CISO or as a cloud security expert, you need to make sure how contoso.com can get rid of data remnants. So the data which is uploaded on the cloud, how do you make sure that the cloud vendor should not be able to decrypt the data? The cloud vendor should not be able to read the data. How you will make it sure? Okay, so the answer to this question is crypto shredding. Okay, the answer to this question is crypto shredding. So now what do you mean by crypto shredding? Crypto shredding means where I am encrypting the data before uploading on the cloud. I am encrypting the data before uploading it on the cloud, and then I am destroying the key so that the cloud vendor will not be able to recover the data. Okay, so I am encrypting the data before uploading it into the AWS S3 bucket, and then I'm getting rid of the key. So this is a perfect example of a crypto shredding or crypto erasure. So now what are the golden rules when we are talking about a key management perspective? The golden rules is you have to protect your keys, keep them safe, know where your keys are stored. So normally in the organization, we normally store the keys on the HSM or even the key inventory. Make sure that you have a proper key inventory. And finally, maintain separation of duties. Maintain separation of duties where one person should not have access to the entire key. Use the principles like dual control and all, where if we have to retrieve the key, minimum two people is needed. Okay, so now when we are talking about know where your keys are stored, so in the organization, they use mechanisms like CyberArk vault and all. They use mechanisms like your CyberArk vault and all, by which you can securely store the keys. Your CyberArk vault is a perfect example. Your CyberArk vault is a perfect example where you can securely store your access key. You can securely store your access key and your secret key. Okay, you can securely store your access key and secret key. Now, one of the best example of this I can give you. So in AWS, okay, I am just giving an example from an AWS point of view. In AWS, for every resource which we consume, it has a access key and it has a secret key. Okay, it has a access key and secret key for every IAM role which we are creating, right? If the access key and secret key becomes compromised, how will you be able to decrypt your data when migrating to another CSP after crypto shredding? So Femi, the thing is that here we are talking about data remnants, Femi. Okay, I have a copy of my data, stored it offline, but I want to make sure now I am moving my cloud services from AWS to Azure. Okay, so now I want to make sure that my AWS cloud provider should not be able to, get hold of my sensitive data. That is the reason what I am doing is I am encrypting the data before uploading it to the cloud, and I am getting rid of the keys so that the cloud provider will not be able to decrypt the data without the key. Clear? Because in the on premises we have a multiple way. Like in on premises we can do the degaussing, we can do the shredding, we can do the pulverizing, but we cannot do that with the cloud vendor, right? That is the reason we have to depend on a crypto shredding or crypto erasure. Now the question is, so in the cloud, when we are talking about an AWS and all, in the cloud we have access key and secret key, which is normally tied with an IAM role, when you are when your cloud account is having access key and secret key, even that access key and secret key, there should be a proper key inventory, and the HSM should also, there should, your access key and secret key should also be hosted on a CyberArk vault. So whoever is accessing the key, the entire access should be audited. Okay, so now one live example of this I can give you. Nowadays many organizations they are going with a DAM product. Nowadays many organizations they are going with a DAM product. The full form of a DAM is database activity monitoring. Okay, now there are multiple products which are there on the multiple companies, product vendors are there who are offering their DAM. So we have a IBM is there. Okay, we have a IBM is there, we have a Imperva is there, then we have a Dig Security is there. Okay, then we have a Trust Logic. There are multiple companies who are offering their own, cloud database activity monitoring products. So many organizations who are offering, many product companies who are offering the database activity monitoring products like IBM, Imperva, Dig, Trust Logic, they have started providing the cloud RDS based monitoring as well. So now you can also use the database activity monitoring to discover sensitive data, to monitor the sensitive data on the cloud. But many of these products, they require the access key and secret key to be stored on the application itself. Now, if you have worked in the InfoSec team, if you have worked in the InfoSec team and in the security team, you know that it's not very easy to get an access key and secret key of an IAM account and store it in a third party system, even though if that third party system is provided by IBM, right? So that is the reason why we normally have a HSM or key inventory like CyberArk Vault and all, where we can upload all the access and secret key, and we can configure these applications to retrieve the key directly from the vault rather than storing the keys on the application. So now we have a different kind of a key management methods team. So we have a remote key management. Okay, we have a remote key management KMS. This is where the customer maintain the KMS on premises. Ideally, the customer will own, operate, and maintain the KMS. This way, the customer can control the information confidentiality, and the cloud service provider can focus on the hosting, processing, and availability of services. Okay, so in the remote key management system, what we are doing is, we are the customer, they are having their own KMS which is maintained on the on premises. Okay, so ideally the customer will own, operate, and maintain the KMS. This way the customer can control the information confidentiality, and the cloud service provider can focus on hosting and processing the availability of the services. But there is a concern when you are using the remote key management system or remote key management service. The main concern is when your KMS is maintained on premises, there should be a hybrid connectivity between the cloud service provider and the cloud customer. Otherwise, the encryption and decryption will not work. So let's say if anyone from the cloud, they are trying to access the sensitive data, but the encryption keys is hosted on your on-prem KMS, and there is no connectivity between the cloud provider and the on-prem KMS, or the connectivity is broken, then the data which is stored on the cloud, it will not be able to decrypt, because there is no hybrid connectivity between the cloud service provider and the KMS. So maintaining a hybrid connectivity, maintaining a availability of the KMS, maintaining a availability of the KMS is a critical element if you are planning to have a on-prem KMS hosted on using for cloud for encrypting and decrypting the keys. The next is we have a client-side key management. Now, what do you mean by client-side key management? Client-side key management is similar to the remote KMS approach, but in this case, the client-side approach looks to put the customer or cloud user in complete control of the encryption and decryption keys. So in the client side KMS, the main difference here is that most of the processing and control is done on the customer side. The CSP provides the KMS. So in the client side key management team, in the client side key management, the software, okay, the software which is doing the key management will be provided by the cloud service provider, but the software is not going to reside on the cloud provider premises. It will be hosted on the customer premises only, where the customer can generate, hold and retain the keys. This type of client side key management we normally see in a software as a service environment, or as cloud deployments, or in cloud deployments. So one of the major difference between the remote key management and the client side key management is, in the remote key management, the KMS is there on prem, which is totally maintained by the cloud customer, and in the client side key management, the cloud service provides the KMS. It means they provide the software, but that software will be residing on the customer premises, the customer data center only, by which the customer can generate and hold the keys. So that is these are the effective key management methods which we have when we are talking about from a cloud point of view. Now, the next important phase in the cloud is the access control with the identity and access management. So access control, so provisioning and deprovisioning the accounts is a critical element of the cloud. So not all the employees, if you remember yesterday when we were discussing about the NIST top 5 features, the on demand self service is a very good tool, but in the hand in if that functionality falls into the wrong hands, it can be disastrous to the organization, right? Because if we provide the AWS console and Azure console access to all the employees, the people will launch instances of larger size, and the organization is the one who has to ultimately pay the bill, because in the cloud we are moving from the capex to the opex. So that is the reason why the AWS management console and Azure management console is not provided to any other employees. It is only there with the cloud team. So now when we are talking about access control, provisioning and deprovisioning the accounts, so you should have a secure way of provisioning the accounts. So rather than depending on a single factor authentication, you should use a multi-factor authentication or biometric, or mechanisms like your Google Authenticator, Microsoft Authenticator, RSA Secure ID. So people who are logging into the cloud, there should be a secure authentication mechanism. Okay, so the accounts which you are provisioning on the cloud, okay, the accounts which you are provisioning on the cloud, there should be a secure way of provisioning the accounts. So let's say if you are talking about username, okay, so username is your identification. Your username is your identification. Apart from that, you have to, apart from the username and password, what additional mechanisms you are trying to have? Are you trying to have a multi-factor authentication? Are you trying to have a multi-factor authentication like Google Authenticator, Microsoft Authenticator, RSA Secure ID? Are you using the biometrics? Are you using the biometrics? All these things are needed for provisioning the accounts. Once the account is no longer needed, the organization should also have a provision to should also have a process of deprovisioning the account. So deprovisioning the accounts means what? Disabling the account, for the employees who have left the organization. Okay, so that no one can use that account to log in into my cloud resource. No one can use that account to log in into my cloud and access any resources. So the access control with IAM, provisioning and deprovisioning accounts, is a very critical element. The next is mitigating privilege creep or access creep situation. Now, what do you mean by maintaining privilege creep or access creep? Let's say we have a person called as Divya. Now, Divya was initially working on the project one. Okay, now Divya was initially working on the project one. Now, the project one is completed. Now, what happened? Divya was moved to project two. But now what happened, that her project one, whatever access Divya one had for project one, that access her account is still having. She's still having that access. This kind of situation comes under the privilege creep or access creep. When the employee is moving to new roles, the employee is getting more privileges than what is needed. One another live example of a privilege creep or access creep situation is when the employee is moving to higher roles. Okay, so like an employee joined as a software engineer, and later on he is promoted as a project lead. So as he goes further, more and more access he is getting. So this directly violates the least privilege principle. So we have to make sure that if an employee is moving to higher roles, or if the employee is moving to a new project, only access related to that project should be maintained. Any other access of the previous project has to be reviewed and has to be revoked. Wherever possible, use the centralized directory service like LDAP or Active Directory. Okay, for centralized authentication and all. Okay, then use the privilege identity management. So privilege identity management, you must have seen many organizations today, they are doing a very heavy investment on privilege identity management, where they onboard all their privilege accounts. Like live example of the privilege accounts, so we have an admin account is there, then we have a root account, then we have a SA account, then we have a sysadmin account. So all your privilege accounts must be onboarded in the privilege identity management. So like there are different vendors which are there in the market who are providing the PIM solutions. Like we have a CyberArk, we have a One Identity, we have a Ping ID. So we can have rule sets in the privilege identity management, where I can define rule set that at what time the privilege accounts will be accessed. So I can define a rule set like the privilege account should be only accessed from Monday to Friday from 9 a.m. to 5 p.m. Okay, I can also define the whitelisting, where I can specify that only the employees connecting from Singapore, Malaysia, Dubai and US should be able to should be able to retrieve the accounts. Anyone trying to connect from Saudi, anyone trying to connect from other countries like UK, or anyone trying to connect from France, there it should be blacklisted. So no one should be able to retrieve the privilege accounts from the blacklisted location. So I can specify the time and geography from where the people will connect to the PIM solution and retrieve the accounts. whatever one of the added advantage of using a PIM solution is that they provide auditing. Whoever is accessing the admin account, root account, SA or sysadmin account, we can we can audit their access, that at what, when, and so we can, with the help of audit, we can capture who accessed, what devices they accessed, and when they accessed. So these are the some best examples of using a PIM. So normally you must have seen that whenever the organization is using a PIM solution and all, okay, make sure that you have a multi-factor authentication enabled for all the privilege accounts. Make sure that you have enabled multi-factor authentication for all the privilege accounts. Review the failed logins consistently. Review the failed logins consistently. Probably you can also set a clipping level. You can also set a clipping level. So clipping level means I can specify if the count of failed logins exceeds 10, okay, in the last 15 minutes interval, if the count of failed login exceeds 10 in the last 15 minutes interval, then I want to get a security incident, or I want to generate an offense. So I can review the failed logins and I can specify the clipping level, that what is allowed versus what is not allowed. Make sure that you are looking for object edits. So when people they upload, when the people try to edit objects which are hosted on the S3 bucket, or when they are hosted on the, when they are trying to access or modify a file in the Azure blob storage, make sure that you object editing is enabled. So anyone trying to modify any object, they are trying to create new accounts, change permissions, upload, delete, modify anything on the cloud, everything will be audited. So these are the advantages of using a PIM solution on the. And finally, we have a authorization and access management. So now what do you mean by authorization and access management? Verifying that the user access identify what they can access and grant that access using role-based access control. So now making sure that the employee has the access which is required for them to do their day-to-day jobs, to day-to-day activities. So in order to grant access to the employees for their day-to-day activities, you can employ using role-based access control. So live example, nowadays many organization, many product vendors, they provide this role-based access control groups. So like one live example is, we have a SharePoint administrators group. We have a SharePoint administrators group. Okay, we have a domain administrators group. Okay, we have a domain admins group in the Active Directory. Then we have an enterprise admin group. We have an enterprise admin group. We have a schema admin group. All these are my role based access controls. All these are my role based access controls. So make sure that you employ role based access control to verify user access and grant only the privilege which is necessary for them to do their job on a day to day basis. And finally, whatever access you have provided to the user, make sure whatever access you have provided to the employee, make sure that you audit all the activity of users, which will help us to reduce the risks associated with the access management, which will help us to reduce the risk related to the access management. The next is team, we have a data and media sanitization. So now what do you mean by data and media sanitization? So in the cloud, we have a in the cloud we have two types of data and media sanitization. As I have already discussed, we have a cryptography erasure and a cryptography shredding. Since physical destruction like degaussing and overwriting are not applicable to cloud computing, the only reasonable method remaining for data sanitization is encrypting the data. The process of encrypting the data in order to dispose of it is also referred to as a digital shredding or crypto shredding. Crypto shredding is basically the process of deliberately destroying the encryption keys that were used to encrypt the data originally. Since the data is encrypted with the keys, the result is that the data is rendered unreadable at least until the encryption protocol used can be broken or is capable of being brute forced by an attacker. In order to perform the crypto shredding, consider the following. The data should be encrypted completely without any clear text remaining. The technique must make sure that the encryption keys are totally unrecoverable. This can be hard to accomplish if an external cloud service provider or other third party manages the keys. Finally, a reliable way to sanitize a device is to erase and overwrite the data it contains. With the recent developments in storage devices, most now contain the built-in sanitize commands that enable users and custodians to sanitize the media in a simple and convenient format. While these commands are mostly effective when implemented and initiated correctly, like all technological commands, it is essential to verify the effectiveness and accuracy. When you are sanitizing the device, once you have completely sanitized, you need to effectively test that whether the sanitization process is effective or not, whether it is effective and accurate. Key destruction on its own is not a comprehensive approach, as the key may be recovered by using forensic techniques. So these are some data and media sanitization steps, crypto shredding and crypto erasure, which we can use in the cloud to get rid of data remnants. So now what are the implications if you are unable to sanitize the data properly? One of the implications is data can be compromised. It can trigger a security incident. It can also trigger non-compliance. It can damage the reputation of the organization, and it can impose heavy fines. So one live example of this I can give you. So if you are unable to sanitize the data properly, if you don't maintain proper data sanitization, or if there is a GDPR breach, then according to this you have to notify the authorities within 72 hours. That is the notification frequency, and you have to pay 4 million euros, 4 million euros, or 4% of the annual revenue, or 4% of the annual revenue, whichever is higher. So now the next is theme. We have a network and virtualization security. Now when we are talking about a network and virtualization security, from a virtualization point of view, 4% ABI, 4% of the annual income, whichever is higher, and 72 hours is the notification frequency. I hope it is clear. 4% of the annual revenue, whichever is higher, and 72 hours is the notification frequency. So now we have a type 1 and type 2 hypervisor team. So type 1 hypervisor, they are your bare metal and native. Live example, we have a VMware ESX server, we have a Citrix Zen server, we have a Microsoft Hyper-V. They are all type of your type 1 hypervisor, which basically provides hardware virtualization. They provide better scalability, they are faster, and they are more secure. But when we are talking about the type 2 hypervisor, so live example of a type 2 hypervisor, like using a Microsoft virtual PC, Oracle VirtualBox, VMware Player, VMware Workstation, VMware Fusion, if you are using a Mac, these are all live examples of a type 2 hypervisor. Now the reason why the type 2 hypervisor is not secure, because on the base operating system itself you are running so many other applications. Like I can take a good example of my laptop, that in this laptop I am currently running a Windows 11. Along with that I am running a Microsoft Office and so many other applications. On top of that I am running a virtualization like VMware Workstation, which is increasing the attack surface. So when we are talking about the security from a cloud point of view, network and virtualization security, because in cloud everything is virtual. So we need to have a basic idea of what is a hypervisor, what is the difference between a type 1 and type 2 hypervisor, and which one is more secure and all. That is your virtualization security. Now there are some, when we are talking about virtualization, when we are talking about hypervisors and all, when we are talking about virtualization, definitely the next part is your what are the attacks which we have related to the hypervisors. So there are two types of attacks which are there very common, which are related to the hypervisor. One is your hyperjacking attack and one is your VM escaping attack. Now what happens in the hyperjacking attack is in the hyperjacking attack, the attacker takes malicious control over the hypervisor that creates the virtual environment within the VM. So once the attacker gains control of the once the attacker gains control over the hypervisor, the attacker can create virtual machines, they can modify the virtual machine, they can delete the virtual machine, everything they can do. That is your hyperjacking. So hyperjacking is basically an attack in which the attacker is taking a malicious control of the hypervisor which is hosting your VMs. Okay, the point of the attack is to target the operating system that is below that of the virtual machine so that the attacker can program and run applications on the VM above it. It will be completely obvious to its presence. The next type of attack which we have when we are talking about from the hypervisor point of view is the VM escape attack. So in the VM escape attack means where the attacker is trying to exploit the virtual machine. The attacker is trying to escape the virtual machine or exploit a code in the virtual machine by which it will allow the attacker to break it will allow the attacker to break out the virtual machine and directly interact with the hypervisor. So in this case, let's say if I have a VMware ESX, let's say in this case I have a ESX. Now in this ESX, I have a VM1. I have a VM1. So in the what the attacker is doing is the attacker is trying to break this VM1. They are trying to break this isolation of VM1. And they will try to break out of this VM and directly access the ESX so that the attacker can cover his tracks, delete the logs, create new virtual machines, everything that is comes under the VM escape attack. So such an exploit can give the attacker access to the host operating system and all the other VMs running on that host. Although there have been no incidents reported in the wild, VM escape is still considered the most serious threat to a virtual machine security. So these are some attacks which we have in regards with the hypervisor. The next is we have a virtual switch attack. So now what do you mean by virtual switch? Definitely in the cloud, everything we are using. So how we have a physical switch and all, we have a virtual switch in the cloud. So the same type of attacks which we have on the physical switches, the same type of attack we have in the virtual switches as well. Now one of the common example of a virtual switch attack is a VLAN hopping. Now, what do you mean by a VLAN hopping? VLAN hopping is a method of attacking the network resources of the VLAN by sending packets to a port that is not usually accessible from a system. The main goal of this form of attack is to gain access to other VLANs on the same network. So we have something called as a VLAN hopping by which we have a switch, we have a network switch. Now in this network switch, I have created two VLANs. My VLAN one, I have created two VLANs. One is sales VLAN and one is your accounts VLAN. So now in the VLAN hopping attack, what we are doing is VLAN hopping means where we are trying to hop the other VLAN. We are trying to access the other VLAN. So now this VLAN hopping can be done by two things. One is your double tagging and one is your switch spoofing. In the switch spoofing, we are using the inter VLAN trunk. We are using the inter VLAN trunk. In the switch, we are using the inter VLAN trunk to conduct a VLAN hopping attack and all. Don't worry, the VLAN hopping, double tagging, switch spoofing are not going to be testable in the exam, but at least you need to have a high level overview of what is a virtual, VLAN hopping attack and all. So in a VLAN hopping, a threat actor must first breach at least one VLAN on the network. This enables the cyber criminals to create a base of operation to attack other VLANs connected to the network. So now in this case, in the VLAN hopping, the attacker somehow was able to compromise the sales VLAN, and now the attacker is trying to compromise the accounts VLAN as well. This is called as your VLAN hopping. So normally the attacker purposely is sending the packets to the account VLAN port, which it is not supposed to send. So these kind of attacks are also very common when we are talking about from a virtual switch point of view. Now, in order to implement security, so we need to have a Balaji in order to, so we have to make sure that, the two VLAN should be completely isolated from each other. Inter-VLAN routing, usage of, inter-VLAN trunks and all, it should be disabled. All that thing are the controls by which we can prevent VLAN hopping from happening. We have to secure the ports by using a STB spanning tree protocol, rapid spanning tree protocol, per VLAN spanning tree protocol. These are all the mechanisms by which we can prevent VLAN hopping from happening. So the next is we have a network security group. So now if you at any point of time, if you would have worked in the cloud, you know that in the cloud we can create a security group which can act as a virtual firewall for your EC2 instances to control incoming and outgoing traffic. Inbound rules, it controls the incoming traffic to your instance, and outbound rules controls the outgoing traffic from your instance. So we can basically configure in the EC2 instances in the cloud with the help of network security group. We can configure what is allowed, from where it is allowed, from where it is allowed, the port using which the traffic is allowed. Everything we can configure in the network security group. So when you launch an instance, you can specify one or more security groups. So you can limit the type of traffic which will be allowed to enter the EC2 or your Azure VM. If you don't specify a security group, your AWS EC2 or your Azure VM, they create their own default security group for the VPC. Later on, you can add rules to each security group that allow the traffic to or from its associated instances. Network security group is the primary mechanism. Network security group is the primary mechanism to control what type of traffic can be allowed to enter the cloud. Network security groups are the prime method of controlling what type of traffic can be allowed to come in. So you can modify the rules for a security group at any time. New and modify rules are automatically, it can be applied to all instances that are associated with the security group. When an Amazon EC2 decides whether to allow traffic, yes, it's a kind of a firewall which is there in the cloud, Abby. When you launch an EC2 instance, when you use an Azure virtual machine, you can create a security group and associate that security group with the instance. So only the traffic which is allowed on that, or that traffic, or only the traffic which you have manually added in that will be allowed. So when Amazon EC2 decides whether to allow traffic to reach an instance, it evaluates all of the rules from all of the security groups that are associated with that instance. So these are the network security groups which we can have to define what kind of traffic is allowed to come in. Now, finally, the last concept of our domain is your security cloud, secure cloud computing and design principles. In this, we are going to discuss the data lifecycle. Data lifecycle is an important element when we are talking from a data, when we are talking about from the design principle. So we have a different kind of stages of data. So we have a create stage, we have a storage, we have a usage, we have a sharing, we have a archive, we have a destruction. The data lifecycle process is in which the data is created, it is used and then destroyed. The data lifecycle changes slightly whether the data is stored on-prem or on the cloud. For the rest of this article, we are going to refer this scenario. So now in the exam, you may get a question asking about in which phase we do the data classification and categorization. Answer is create stage. In the exam, you may get a question asking about in which phase we do the classification and categorization of the data. Answer is create stage. In which stage we are using BitLocker drive encryption to protect the confidentiality and integrity of the data. In which kind of data we are using a TPM protection. We are using a TPM or BitLocker drive encryption. The answer is your storage stage. Okay, the answer is your storage stage. In the exam, you may get a question DRM. Okay, your DRM, digital rights management, your masking, okay, your masking, your tokenization, all these, it protects which kind of data? The answer is data in use. So we have a DRM, we have a DRM, we have a masking, we have a tokenization. These all controls are there to protect the data in use, which is there on my physical memory. Then you may get a question asking about in which stage we use VPN or SSL TLS certificate to protect the confidentiality and integrity of the data. Answer is your share stage. Because we use the SSL TLS certificates, we use the IPSEC VPNs to protect the data which is exchanged over the network. That is the data in transit, right? So that is my share stage. Your data retention policy, okay, your data retention policy which we have in your organization, that it comes under the archive stage. That comes under the archive stage, your data retention policies and all. Finally, your crypto shredding and crypto erasure, that comes under the destroy stage. So once the data is no longer needed, we destroy it by doing a crypto shredding, crypto erasure, degaussing, and your destroying the disk. All that comes under the destruction stage. So this is the entire data life cycle we have in the cloud. This is also there for the on-prem as well. Finally, the one of the biggest topic which we have is your data governance, the last topic of this slide. So data governance is basically everything which you do to ensure that the data is secure. So now when we are talking about data governance, so what is a data governance? Data governance is everything you do to ensure that the data is secure, private, they are accurate and available and usable. It includes the action people must take, the process they must follow, and the technology that supports them throughout the data lifecycle. So every organization must have a data governance policy which talks about the internal standards. It should have the data policies that apply to how the data is gathered, stored, processed, and disposed. It governs who can access what kind of data and what kinds of data are under the governance. So like live example, in GDPR, we have the PII data of European citizens, which comes under the data governance. Under the HIPAA, we have the PHI data, which comes under the data governance of the HIPAA regulation. So every organization must have a data governance. So every organization, it is must for every organization to have a proper data management. It's all about the trust. With the help of data governance, you can capture what is your data and where is your data. In order to apply a proper data governance, you should know what are the sensitive data which your organization is having and where your sensitive data is. If you don't know where your sensitive data is, then you cannot protect. So that's a simple thing. So that is the reason nowadays many of the product companies, they are providing the data discovery tools like data discovery tools by which you can locate the sensitive data which are segregated across in your organization. So what are the benefits of data governance on a cloud? It makes better, more timely decisions. It makes better, more timely decisions. Users throughout your organization gets the data they need to reach and service customers, design and improve products and services, and seize the opportunities for new revenues. It can also improve the cost controls. It helps you to manage the resources more effectively because you can eliminate data duplication caused by information silos, and you don't overbuy and have to maintain an expensive hardware. So you are only protecting the data which is critical. You are not protecting the data which is not sensitive to the organization. By by having a proper data governance, you are also enhancing the regulatory compliance in the organization, which is an increasingly complex regulatory climate has made it even more important for organization to establish a robust data governance practices by which you avoid risks associated with the non-compliance while proactively anticipating new regulations. So one of the biggest risk when we are talking about the data governance in the cloud is the data localization, where your data is stored, right? So in this case, if I am protecting my, if I am compliant, if my organization is compliant with the HIPAA regulation, if my organization is compliant with the GDPR regulation, then according to that, I need to know where my data resides. So where there is a civil unrest, or I cannot have my data replicated into those countries where there is a civil unrest is going on. So in the cloud, the primary objective of protecting the data is to know where your data resides. So these are the benefits of the data governance on the cloud.